Thank you. Thank you. Morning, everyone. Last week, we talked about some of the key soil health issues that are causing major agriculture economic losses. So, what we are going to do, we're going to quickly recap what those issues are and how should we overcome them. Number one is the loss of topsoil. This is the first and foremost. We should focus on minimizing erosion, losing our topsoil, whether it's blowing away, whether it's running off, or by any other means. Tillage erosion is another thing which is being recognized more and more. Mostly we used to focus on wind and water erosion, but tillage also causes erosion. Then decreasing soil organic matter levels, soil salinity, sodicity, high magnesium levels compared to calcium. To some people, this is a concern. To some, this is not. But in my view, we should think more about it and then find ways to overcome that because it causes swelling of the soils that slows down soil water infiltration and then excess soil water. So just to start off quickly, again, I would like to quickly differentiate soil sodicity versus salinity because they are often mixed together. They're often confused with each other. So salinity is caused by excessive levels of water-soluble salts, and salts are a combination of two chemical ions. One would have positive charge, other one would have a negative charge. For example, table salt, sodium chloride, and they both are chemical ions. Sodicity is not caused by sodium, which is present as a salt. Sodium, when it gets attracted to the negative charges of soil particles like clay or humus, that's when sodium causes sodicity. If it is present as a salt, it would cause salinity. And the best way to assess, we could keep guessing. In this picture, you don't see any white salt crust, and there was some germination, but in some pictures, actually, you would see white salt crust, but still doesn't tell you how high the soil EC is. And if we don't know that, we will not know what to plant there, which will grow. And leaving these areas bare actually make these issues worse. So we need to figure out what is our soil EC, and based on that we could figure out whether we should plant an annual crop, or even sometimes annual crops are not an option. Then we should go with the more salt tolerant perennial grasses. Sodicity is even the symptoms are not there. So the best thing is take a soil sample, get it analyzed from the lab. Just to recap again, salinity, the major effect it has on plants is it deprives plant roots of water. So salinity directly affects plant growth. It doesn't affect soils per se. Sodicity, on the other hand, doesn't affect plant growth directly, but because it affects soils in a severe way, causes these dense soil layers due to the breakdown of soil aggregate, and that process is called dispersion, that it slows down soil water infiltration. So not only it itself has issues, poor seed bed, poor seed germination, crusting, and other things. But then salts will also accumulate more because soil layers are dense, porous space would shrink, and salts cannot move downwards. When we think about managing these issues, we should think about landscape. We should always focus on that. And I think we are lucky to have a tool like Google Earth. It gives the land elevation. What I did, I just went to Google Earth, took this picture, and if you hover over your cursor, it gave me the elevation here to there, so I could see where the water naturally could go. It helps you devise a good plan. If you just go and start just doing things on one spot and not look what is on the other side of the highway, even though it may be your neighbor's land, that will help you understand the problem better. And once you understand the problem and understand the root cause, you can manage it better. Same headland, like we said, these headlands are actually acting like wetlands to me, because we stop the natural flow of the water going, say, on the other side of the highway in this case, and then there's these ditches also do not have good flow. So then this water vicks up towards the higher productive ground, and result is very big rings of unproductive areas. There we just lose money. first step, like in the first picture we saw when the farmer was wondering actually what was going on in his field, beautiful patches of wheat, and then suddenly there was nothing. Sampling. So we have to create zones. Grid sampling probably will work for uniform areas for fertility, but for these saline sodic areas, because they're not uniform. There would be one pocket here, one patch here, one ring here, and then there would be good area, and then there would be one more there. So you have to kind of like create zones. And then we like to go 3 to 4 feet deep in 12-inch increments, because unlike nutrients, salts and sodium, which causes sodicity, can move up and down quickly. And the test which we need to assess salinity sodicity are electrical conductivity and sodium adsorption ratio by using saturated paste extract method. If you have already established that there is a problem of sodicity or higher magnesium levels compared to calcium, we would need amendments. And then we would need another test, cation exchange capacity or CEC, by using sodium saturation method. This is just an example. I created these zones. So if you look at the red triangle, there are white areas there. If you want to know what's going on in those white areas, even within this zone, you do not want to mix soil from the gray areas, which probably is good soil, versus the white areas. You only go take 2, 3, 4 cores, depending upon the size of the area, from the white areas, and then separate the depths and mix each depth from each core, and then make that sample. That would represent that white area. And here's what we are doing. I normally keep 4 buckets in my pickup, but you could have Ziploc bags, paper bags, just have something which doesn't rip easily. And what we are doing, say if we took 3 cores, say if we go back here, we took 1 core here, 1 core here, 1 core here. From each core, we'll mix the 0 to 12-inch depths together, and we'll follow the same procedure for the other depths. Label them clearly, send them to the lab, and be very clear. Not only what test you want, say ECSAR, CEC, but what method you want the lab to use, because that can make a huge difference. If you have established sodicity issue, sometimes it's economical, sometimes it's not economical. The current source of gypsum we have in North Dakota, it basically costed us, it comes from Washburn. We got about 380 tons in 2018 delivered to a research station. It cost us $40 per ton transportation cost. But if before this source, I actually paid $250 to $300 per ton delivered here. So cost can make a huge difference, but say if it is economical, sodicity will not happen unless your sodium levels are way lower than calcium. So if that's the case, that means you'll have to raise soil calcium levels by adding more calcium, and gypsum is calcium sulfate. So say you spread it, you have to till it in or incorporate it in so that the gypsum particles are in close contact with soil particles. And then calcium will separate from sulfate with the help of rain. And we should not underestimate that, because if we get dry, this amendment is just going to sit in the soil. And then calcium will displace sodium from soil particle exchange site. Sodium will come into the soil water, attract a negatively charged ion, and would become a salt. And then it's ready to move with the rainwater. Same goes for the magnesium issue. In my personal view, again, some people perceive this is how our soils are. My argument is that sodium is also the same thing. This is how our soils are. It's coming to the topsoil, and at some point in time, it just makes a ratio between calcium to sodium not really balanced. So we recommend amendments for that. Well, magnesium, it's established that in the shrinking and expanding soils, it could cause swelling, not dispersion, not breakdown of soil aggregate, swelling of the soil. Result is shrink pore space and slow soil water infiltration. So same thing, we will apply the amendments, incorporate, and then calcium will displace magnesium. Once we do that, so number one thing is we want to apply the amendments, because if you did that later after planting something, then in order to incorporate the gypsum, you would basically be destroying your crop or grasses. So you want to do the amendments first, if that's what you want to do. And then once you do that, look at your soil EC. The most salt tolerant options you have are barley and oats and sugar beets to an extent in our areas here, Red River Valley, for example. And the surface soil salinity here is 3.99, which is quite high for soybeans and corn, and in some cases in a dry year, even for crops like wheat and canola. But barley and oats are doing very well. Once you exhaust these options, then you will have to go to, say, perennial salt tolerant grasses, just like in this picture. Grasses are growing everywhere. Alfalfa is not really a salt tolerant plant, even though some varieties may be sold as salt tolerant alfalfa, but I would not rate it as even as high as barley and oats. And we discussed the economics too. We will lose not only way more money if we just followed the annual regular cropping rotation instead of, say, planting. I'm not including even barley and oats here, but I'm just focusing on regular crops versus planting the um, perennial salt tolerant grasses. Not only will save about $350 in 4 years, but that will help the land, get better. Buffer strips. I cannot emphasize more on the importance of buffer strips, whether it's the headlands along the roadside ditches, whether it's along the infield ditches, whether it's around the wetlands. And again, you could soil test first, but I would say one thing to you, going by the look of this area. These areas are so saline that even barley and oats are not going to do any good. So you want something perennial. But I want to emphasize, not all perennials are salt tolerant. Some are not. So pick the ones which are salt tolerant, which will grow. That's the number one thing. They will reduce evaporation. And then some are very deep rooted, like western wheatgrass. Its roots can go 5-6 feet deep in 3 to 4 years if we manage them. And by that I mean either mow them, hay them, or graze them. Tiling. Tiling to me has been advertised without any repercussions. It's presented as one step solution. There are no negative effects, no side effects, nothing. And it costs you a lot of money to do that. To me, we should do our homework. Tiling will work if we have excess soil water and good soil water infiltration. And good soil water infiltration is a direct result of good soil particle aggregation that will result in good structure and pore space. And if you have dispersion going on or swelling going on, your soil water infiltration will slow down. So please do your homework and get your soils tested for EC, SAR, and calcium, magnesium, sodium tests through saturated paste extract method before you make a final decision. Trust me, that would be much cheaper than just going ahead and tiling. So Heather, this was my quick recap, and we could take the questions at the end after Tanner's presentation, or whatever works for you. You decide.
Whoops. Okay. I think we'll take the questions at the end, Naeem, if that's all right.
That's
and
perfect.
We'll let Tanner go ahead and share his screen. Tanner Bruse is with the Pheasants Forever, and he's going to get us started in his presentation. And then at the end, we'll try to answer the questions that are coming in. So if you don't mind, Naeem, stay on with us, and we will see you at the end. Tanner, we see your presentation screen. You
see it? Is it full screen?
No.
Presentation view right now.
Yes.
I never claimed to be great with technology, so when it comes to computers, but.
Do you have two screens, Tanner?
Yes.
I do.
I think that's the problem.
I think you grabbed the wrong screen to share. So.
Leave it up to me.
That's all right.
How's it look now?
You're good.
Perfect. Well, thanks for hanging in there with me. I always say it's not a Zoom presentation without a dog barking, a kid popping into the equation, somebody talking on mute, or some sort of technical difficulty. So again, thanks for joining. Obviously, it'd be great to be in person and have the in-person conversations with everybody. But we will take what is given to us and we'll proceed. My kids are at school, so we shouldn't have to worry about a kid popping in. My wife is home. She also works from home, and I have a dog. So we'll see if there's a dog bark that I can provide for everybody here as well. Just start off with a little bit of myself. So I grew up in Southwest Minnesota with really two passions, and it was instilled through family. So if you can see it on the bottom left, that's Southwest Minnesota Livestock Sales Pavilion. My grandpa owned the sale barn for numerous years, went through two generations. Unfortunately, it didn't make it to a third or even a fourth. But that taught me a lot of things about farming, about agriculture, about livestock, and really grew an appreciation for everything that happens on the landscape. I always tell people one of my fondest memories is every Tuesday having a beef commercial with the smell of manure around me. So that was a big part of my life. Also, if you see on the bottom right, that little guy down there is me. My dad was an avid outdoorsman, and he really shared that conservation ethic and that passion with me as well. As we grew up, my dad and I continued hunting. I started my own family up in the top left, me, my son Bo, my son Wyatt, my wife Heather. And I guess I put it like this. I have a passion for conservation. I have a passion for agriculture. I landed in a position that lets me work with both, which I'm grateful for. And now it's my turn to pass on the tradition and show my kids what it's like to live on gravel roads and flyover country. So huge passion of mine. Excited to be here and talk about what Pheasants Forever is doing. So just a little overview. So we're going to kind of run through who is Pheasants Forever and how did we start, what kind of positions we have and where we're working. Talk about precision ag and conservation and how we view technology and how that can be implemented on the landscape for both farmer profitability along with providing conservation alternatives. We'll run through a couple examples, and then I do have one example that I'll be sharing that's based on salinity solutions and the profitability focus and what was done on that field as a remedy. So Pheasants Forever. Who is Pheasants Forever? Who are we? And also our sister organization, Quail Forever. So Pheasants Forever itself was established in 1982 in Minneapolis, Minnesota. A bunch of passionate outdoorsmen really just came together, decided that they wanted to see more pheasants on the landscape and more habitat for them, and started with one big banquet. And here we are today with 750 chapters throughout the country, along with 130 to 140,000 members. Oftentimes we're known, as you can see on the left-hand side, for our banquets, which gathers people for great camaraderie, great drinks, great food, great prizes, and oftentimes known locally within that local community as a great place to go, a great place to spend time. We have a grassroots model. So at those local banquets, every dollar that's raised locally gets decided how it gets spent locally. The only thing that comes back to the national organization is a $35 membership. And that's where we get the 130 to 140,000 members. So oftentimes locally we're known for banquets, but we are the habitat organization, and our focus and our mission is habitat. Going on to our field staff. So we've got a couple different directions here. Starting in 2003, we started partnering with your local NRCSs, soil and water districts, and really saw a need to help emphasize wildlife habitat and help farmers, help landowners implement and enroll in programs. And from there in 2003, started with 4 Farm Bill biologists in South Dakota, actually. So Farm Bill biologists, they're co-located within NRCS or Soil and Water District offices. They're specialized in state and federal programs. I guess we like to call it the acronym SOUP, which we'll hear more about also next week with Alan with the Natural Resources Conservation Service. And they really work directly with farmers, with landowners. And I guess what we like to say is try to take it from A to Z. So the initial conversation on, what that individual, what that farmer's goals are, what they're looking to do, and then explore the opportunities and options out there and really go through that alphabet soup and figure out which acronym it is that would fit that property the best and fit the farmer and the landowner's goals. Second would be our precision ag and conservation specialists. This was established in 2015. Our first position was in Iowa. So with the different technologies out there in agriculture, it was identified as far as the opportunity to kind of bring conservation, into the 20th century and really utilize the technology that's out there to showcase how you can focus on your profitability, provide conservation alternatives, and show how they both work on a farm and in a field. It's not all or nothing for either row crop production or conservation, and how, when combined together, we can really increase profitability, which is the #1 goal, and then again, provide those conservation alternatives. So the precision ag and conservation specialists, we currently have 8 individuals on the ground, 3 in North Dakota, 1 in South Dakota, 1 in Minnesota, soon to be 2 in Iowa or in Wisconsin, 1 in Iowa, and 1 in Georgia. We do have more positions coming underway, but really the #1 goal in this is to utilize the data and the technology to figure out producers' goals, analyze the data, dive more subfield into profit per acre, and then work with that landowners, that farmers, trusted advisors to really dive in and look at not only just conservation alternatives, but what can we do agronomically and what can we do conservation wise to kind of tag team and go hand in hand lockstep and do what's best for profitability and in turn get all the other benefits that come with it. As you can see in the map up here on the top right, maroon dots are where we have Farm Bill biologists, which we couldn't do without our various partners, both on the state and federal side, along with the blue dots being the precision ag and conservation specialists. So here we jump into precision ag and conservation. Since the beginning, we set this vision statement and haven't changed it since. Our vision is to demonstrate through the use of technology, collaboration, that farmers will increase their profitability while also providing benefits for soil health, water quality, and wildlife habitat. Everything that's done through this is 100% free, 100% voluntary, and really leads to the boots on the ground and providing that technical service. So let's start with kind of the first example, and I oftentimes go to this one first because it holds a special spot for me because it was one of the first projects I worked with and really started identifying and seeing the opportunity there is when you're looking at data, profitability, diving in subfield, and what those conservation practices look like financially after implemented. So in this example, this one was in kind of western Minnesota. You can first start and you look at the far left, which is your yield map. That tells one story. You can look at that whole field and the yield and start throwing in some financials into it. And what you come out with is the average yield in this year of 145 bushel per acre, which led to a profit of $41 per acre. So one could say we made 41 bucks an acre. Let's move on to the next field. But if you see here, we have a sandy ridge cutting through the field. that just lights up red. Also down here, we have another red area, which is next to a river. So as you can probably imagine, water issues are what is causing the issues on this farm or on this field. As we talk about salinity issues, and I'm really looking at the data and the technology and the goal of taking a red acre, which is unprofitable, and turning it green, which is profitable for the farmer. I would say it's all interchangeable as far as what's causing that, but I'm going to focus today on what the solution is and how that changes your bottom line. So you look at this as a whole field, we're making money, but we have these red areas. What does that mean? What are the true numbers behind those red areas? And as you can see kind of on the map here, when you start averaging it out on here, sorry, I got a little screen in my way here. When you start averaging out, average yield on these red areas, 75 bushel per acre. Definitely a big downgrade from the average yield of 145. The profit, or should I say loss, on these red acres is $250 per acre, which everybody can imagine really has an impact on the bottom line and the effects over the entire field. So I also want to note that this field was had a renter and a landlord, and both of them agreed that we need to do something different on these acres because the farmer wasn't being successful on these acres, and the landlord themselves understood the issues and wanted to do something to help that farmer. So after looking at goals and priorities and identifying the different opportunities out there, I guess what was settled on was CRP. And as you can see in this is a Google Earth. A year or two later, you can actually see the establishment of the CRP on those acres, which I think is pretty cool. And another testament to, I guess, what Naeem was mentioning and just the technology we have and what that can do for us. So through working with this farmer, also this landlord, and then also their crop consultant, I can't emphasize more working with the farmer's trusted advisors. We were able to set up the boundaries on this to make it as feasible as possible to continue farming it and pretty much operate that field under the same conditions they were previously as far as equipment width and the different boundaries. So what did it mean financially? We increased our average yield from 145 bushel per acre to 157. We increased our profits from $41 an acre to $86 an acre, and that's over the whole field. So making a change on these 25 acres of CRP allowed the dollars and cents to go up and the average yield to go up on that field. And as you can see on the far right, that's after implementation, and I went out and took a picture of the establishment process. Another project here, this one's actually in southeast North Dakota. It's about 13 acres, as you can see on the far left-hand side of the field here. Overall, this field was producing 155 bushel per acre and losing $50 per acre on average across the field. As we started looking and diving into the data and the different metrics and plugging in the profitability analysis, just showcase that year after year on the west side of the field just continued to light up red. So that farmer knew something had to happen, had to do something different. So after looking at the different opportunities, the different programs, he actually decided that he has an adjacent pasture and it made more sense and there was enough financial gain for that individual to actually go out, put the fence up, plant it into perennials, and open that up for his cattle to forage. In the end, by making that one change on this 13-ish acres, it increased the average yield by over 22 bushel per acre and increased the profit by $63 per acre, going from a loss of 50 to a profit of 13 per acre. Obviously, as most of you know, there's a lot of variability within what the data is going to tell you and the different metrics, such as, is it owned versus rented? What's my land or what's my rent payment? What are my farming practices? What's the input price? All those are going to change from farm to farm, from family to family, and even from field to field as far as what those cost metrics are. And obviously those are going to change how it shows up on a profit per acre basis. Next, we have a Northwest Minnesota project. As you can see, again, we're looking at the red acres and what can we do to remedy those red acres and again, turn them green. So after looking at different years of data, down on the bottom right-hand side, it just continued to light up red and consistently be unprofitable. Again, we're looking for the most feasible acres to make a change. We might not take something in the middle of the field and make a change just for feasibility. So in this case, down in the bottom right-hand corner on the boundary of the field, made a lot of sense to do something different there. So like I mentioned, after looking at numerous years of data and seeing this spot continue to light up red, this individual decided they wanted to do something different. After a couple different applications to enroll into EQIP and 327 conservation cover, which I'm sure Alan will talk about more next week, it was accepted, and that will be planted this spring into a pollinator mix. So I mentioned looking at years of data. So obviously the more data, the better as far as years. So that's the quantity. The quality also, I want to emphasize how good is your data? Does it need to be cleaned up? How often are you calibrating? Another point of emphasis that if you're really looking to dive deeper into the metrics, those are considerations to take. So on this field, again, looking for the most chronic and the most feasible to create win-win situations, and take those red acres down on the bottom, which over that entire field, the average yield is just shy of 37 bushel per acre. The selected area down here on the right of 5 acres, the average yield on that is just shy of 22 bushels per acre. So at $14 beans, you can do the math on what that difference is financially. To take it a step further, I guess it's looking at those red acres and not necessarily just washing that away. We're also looking at taking the green acres or the yellow acres and how can we increase profitability on those? So by taking and looking at your working capital on those 5 acres that we did something different with, that we enrolled into a program, that we planted into perennial vegetation, whatever it may be, let's take the working capital from those 5 acres and let's put it on our best producing acres. And what kind of changes does that mean? Does it mean, a different genetic with our seed? Does it mean another pass? What is it, and where can we put that to use the best by saving some money, making more money on some acres, and spreading it across the entire field? So with the main topic of being salinity, obviously I couldn't leave today without showing one example that included some salinity issues and I guess how that creates red acres. As you can see on the top left, as Naeem was mentioning, you can definitely see the white spots and where the issues occur. If you look on the hand side, utilizing Google Earth again, you can see it, looks like snow caps, but that's not. Those are salinity issues in that field. Direct correlation back to profitability, and also which incorporates yield. As you can see where we have white on the aerial imagery, lights up the most red on the profit per acre. So as you can see, on these areas, we're losing over $200 per acre the way it stands today. So what are the different options? What's the different opportunity within this field? This individual decided that forage barley would be the best option for remediation, and use that for hay production. So as you can see on the bottom, this is after planting, forage barley. You can see early establishment, there were some areas that were not successful, but as it continued on, the success of that plant growth continued to get better and better. So by making this change on just your salinity acres, so on the map on the right where that yellow boundary is, that's what was planted to forage barley. The individual increased their average yield over their whole field by 7.7 bushels per acre. And if we start diving into profits, it increased the whole field profit by 23.5 bucks per acre, which in turn, if you look at return on investment, it also jumped up return on investment by about 16%. So again, just another option. This individual could have chose to look at, different conservation programs, could have chose to try different things, could have looked at doing perennials. But in this case, forage barley was the choice, and we'll continue to monitor the success of that implementation and how it continues to change and adapt to the salinity issues. So looking at our problem as a whole, as far as salinity goes, and again, looking at wet acres, sandy acres, whatever it may be, this is what we as an organization see as an opportunity, and how we go after it for working with the farmers. Number one is understanding the operational goals. It's all about the farmer. It's their property. It's their data. It's their decisions. So again, 100% voluntary. And what they're looking to do is number one. Second would be looking at, what kind of data do they have? What kind of platforms do they utilize? Do they have as applied, as planted data? What's the quality of the data? From there, once you decide the data meets the quality metrics, you start looking and analyzing the operation with the trusted advisors, with the farmer themselves, and start exploring the different options and the opportunities. Last would be, the end goal of plan and implement. So what are we looking for opportunity? We're looking to increase profits, first and foremost, increase return on investment. Over time, the increase in APH, and then obviously, let's square these up and make them feasible to farm and do what makes sense for the farmer themselves. Also on the decrease side, what are we looking to decrease? Decreasing risk, wasted inputs, and decreasing the break even. So what are the different solutions out there? What kind of things can we explore? Obviously, we went through a few of them here today, but first off would be your perennial cover. This is voluntary. Do you want to look at different programs and how that impacts your bottom line? Or do you just want to do something on your own and potentially use it for hay or whatever else that you need? Second would be, soil health. What kind of soil health practices can we utilize, such as cover crops? In one instance, we worked with a grower that actually planted cover crops, harvested seed, had it cleaned, and then he utilized that seed over the rest of his operation. And that was just grown on red acres. That individual wasn't looking for mass production or quantity, but that made an overall impact over the operation without having the need to buy the seed themselves. Next would be, is there potential to add a small grain or add a crop back into the rotation? If you have livestock, it's a great opportunity to add forage, add pasture, increase your bottom line, potentially increase your herd size, whatever it may be. And then are there future crops in new markets such as Kernza that could also impact and play a role in your decision making and what's feasible within your area? So there's a lot of different options, a lot of different opportunity. It's hard to say that there's as with any farm, it's not a one size fits all. So working with the farmer, deciding what makes the most sense to them, goal number one. with that, I'll just thank you for having me on here today. My contact information is on the screen. tbruce@pheasantsforever.org. My phone number, 507-865-1163. Be happy to have discussions online or offline, share some different resources with you, and look forward to talking to you. Thank you again.
Thank you, Tanner. Angie, do we have some questions that came in?
We do. Oh, there's Naeem. Thank you for participating. If you have more questions, please be sure and put them in the Q&A box at the bottom of your screen. But in the meantime, we do have a couple of questions that came in through the registration process and then through feedback from last week. And then I have a couple of additional questions. So one gentleman, Matt, asked whether there was a legume that tolerates salinity.
So generally, legumes are not really salt tolerant. But if I have to compare, say, for example, peas versus clovers, I would say clovers are mostly salt tolerant, even more salt tolerant than alfalfa. Having said that, if you say planted a legume, for example, like alfalfa with perennial grasses, what we found out that grasses kind of like nurture alfalfa. So that's a totally different effect. It has got nothing to do with the salt tolerance of alfalfa, but grasses help alfalfa. And most of the crops or plant types would be very sensitive at the time of germination. But once the seedling is there and it's established, it could tolerate a little bit more. And we have to also quickly understand this, that salts basically compete with plants for water. But in a year, if we get lucky, we planted the seed, there was plenty of moisture. And if it keeps raining, decently, say half an inch after every other week, there would be no shortage of water. So you could get different results in different years. So, but generally, I would rate clovers as more salt tolerant. After that, alfalfa, and then say field peas, for example. So sweet or red clover, any one of them would be a better choice.
Great, thank you. And Naeem, when you were showing us your strategy for how to collect soil samples in the field, you were saying a person should go down 3 to 4 feet and then separate the different depths and combine samples or subsamples together. So, obviously people aren't, it's not like people sample soil just for fun or something. And going down that far is it's going to be some work. So how many subsamples would a person have to take to have a good and representative sample from a particular zone, for example?
It depends upon the size of the zone. So for example, I generally, if I look at a zone and if it's a 5-acre piece, even within that 5 acres, for example, producer tells me that I'm only worried about these dead spots, for example. So the number one question and by the way, we have a pickup mounted probe and we do help producers for free. We don't charge them for our services. We coordinate the date and time with the help of extension agents. We go out there, help them with sampling, and then we give them the list of these are the tests you would want the lab to do through these methods, and they have a choice of sending them to, say, AgWise or any university lab. And once the results come, then we sit down again. Today, actually, I'm going to go and meet a farmer with the county agent. We help this producer with soil sampling. Now, today is the time to discuss the results and the options for remediation. So say it depends upon the size of the area we want to sample, but I would say it could range, whether you call it subsamples or cores. It would be at least two. I would not just take, say, one core and say there are 4 biggest spots, widest spots. And he's saying, I want to know what's going on here because nothing is growing. If there are 4 and they're distinct and they're uniform, I would go to each spot, go 4 feet deep and say I have 4 buckets, I'll separate all 4 depths, go to the second one, do the same thing. Sometimes actually on both sides of the highways, it's the same thing, and farmer owns the land, we go take 1 core on one side of the highway and take another core on the other side. So 2 to 5 at most, I think. And when I say 5, that means it has to be a very big area. So generally I take 2 to 3 cores to make 1 sample.
Great, thank you. So Tanner, you know, not taking into account how long it might take for like a program to get implemented through NRCS, what is the average timeline for the Pheasants Forever Precision Ag program? So from the time a farmer contacts you until you are done working with them and analyzing their data and talking through a solution?
Yep, perfect question, Angie. So, you know, as it starts, it's going to depend on what time of year the conversation starts, obviously. But the initial contact is made. Our precision ag and conservation specialist goes and meets with the farmer, ideally on site. You know, with COVID, things have changed and depends on people's comfortability level with that. But with that being said, once after that first consultation and kind of the producer's goals are made, we would dive right into looking at data and starting to analyze the operation. Obviously, like you said, if you're going to enroll in a program, there's different eligibility requirements. You know, is it open? Is it not? Those types of things. But I would say, you know, within 6 months, we should at least be applying for something, if not already accepted into something. And again, that time frame can be extended further than that. But if you're just looking at doing something on your own, not really looking at a program, hopefully the next planting opportunity that spring, that change could be implemented. And you obviously have to take into account, you know, does that individual already have they already bought their inputs? Have they already bought their seed? So do we have to wait until fall to implement, or do we have to wait till the next spring? So on our end, as soon as the contact's made, the process is going to start. That's the short answer, is the process will start as soon as the phone call is made.
Right. Yes. Well, thank you for that. We did have some questions that came in after the session last Friday. And I'm going to read this. We don't have a name attached to this because the all of the input is anonymized. But here's one question. So one of the examples that Naeem shared was a farmer using grass and legumes to improve the soil and then putting it back into small grain crop production. What's the potential for that area to eventually revert back to an unproductive area if drainage patterns and tillage practices remain the same?
There is as much potential as possible. So if we look back and look at the root cause of these issues, we have lots of salts and, you know, sodium deep down in our soil. Every time there would be a shallow groundwater depth, you know, when we go through wet weather cycle, those salts are going to come and accumulate in the top soil layers. So if you don't maintain that, and I don't know, I thought that we entered a dry cycle in 2017, and we are kind of like drier, a little bit drier than say whatever the rainfall we were getting up to 2016, but it's still, sometimes you get a lot of rain and you think, okay, I was thinking wrong, probably. We are still in the wet cycle. So the thing is, we have to manage and maintain these areas. If we do not do that, yes, there are great chances that these areas can go back to where they were. This is why I'm in the favor of perennial buffer strips. So say, for example, number one thing is the amendments. Okay, so we have to understand that perennial grasses will grow on these saline sodic areas, but they won't change the soil chemistry. They do take up some salts, and, you know, you hay them or graze them you're taking them out of the fields, but it will take a long time to get these areas remediated through say plants. And then there's more coming from the bottom up too. So when we talk about managing this water, for example, along the headlands, which would be along the roadside ditches or the infield ditches or the wetland, this is why I like perennials, because the roots don't die. Right now there's snow on the ground, but whatever perennial cover is, the roots are still, doing things in the soil. Come spring, these plants will turn green again, and they would intercept that water. So we have to kind of like have a plan. We cannot really say that we applied the amendments, okay, we improved these areas, now I'm able to plant wheat, soybeans, for example, and then that's it, I'm not going to counter this problem again. No, we have to kind of like, be vigilant about it. Otherwise, weather conditions, our management can make things worse again. Long answer.
Thorough, complete answer. Thank you for that. Tanner, how many inquiries have you had from Northwest Minnesota? Have you had a lot of people contact you to be a part of your precision ag program?
Yeah, I would say it's growing. We've got several really good conversations going on right now, and in some cases we've been working with that family, that farm for a couple different years now. Obviously, not all the changes are going to happen immediately, and it's not a one-time thing where you have a conversation with somebody and you move on to the next. You're going to continue that conversation with that farmer. You're going to make sure what was implemented happened as you planned it to. And you're also going to start to identify different areas and maybe kind of grow in your conservation delivery as you continue to see these changes and these improvements. So we've got pretty much all across Western Minnesota, from Northwest Minnesota to Southwest Minnesota, growers that we're working with currently, and future inquiries and plans to meet with more. So it's a scale that's always changing. So I can't just say we're working with 20 people, because some of the people are brand new and we're starting from getting to know each other all the way to the 2 or 3 year relationship, and continuing to work with them. But it's definitely growing. You can see a lot of different platforms out there. If we start talking about precision ag, are focusing on profitability and starting to look more sub-field. So it's growing in popularity, and as everybody says, farming is a business. It's a passion, but you also have to make money. So how can we utilize the technology to make common sense win-win situations for profitability? And then also, once you start looking at sustainability and conservation and environmental and whatever other words you want to throw out there, if we can also provide those at the same time, it's definitely a benefit.
Great, thank you. Naeem, how does deep tillage to compacted headlands affect surface salts that exit on these headlands?
For the most part, if you're doing deep tillage, and especially in the Red River Valley, we have shrinking and expanding type of soil, so that will not help. For salts, actually, it makes sometimes things worse. The only time I see the place for deep tillage is if you have severely dispersed soil layers, for example, due to sodicity, for example, and you spread the amendment, say you spread the gypsum, you till it in, regular tillage equipment will go, say, 4, 5, 6 inches deep. You mix the gypsum in the first layers. The key now is how much water we are getting and how fast gypsum is moving through the soil profile. And as it will move, it will help build soil aggregation, improve that. So at that time, to me, if you have non-shrinking and expanding type of clays, which are in some parts of the, say, North Dakota, I don't know whether you have those kind of a clays in Minnesota too. Dr. Dave Frenzen did some research, and the examples could be illite or kilonite. Those kind of a clays don't really shrink and expand. If you do the amendments and then you did the deep tilling, and but when it comes to deep tilling, we have to understand where is the tip of that hard pan or the compact layer and what is the bottom of it. Generally, the tip of that hard pan is whatever is the depth of a regular tillage. So if we do tillage at 6 inches, that would, if you dig up the soil, the tip of that hard pan will start at 6 inches. And then say, for example, if it is 12 inches thick. Now, if you really want to do deep tillage, and if you want it to be effective, you want to go below 18 inches then. Otherwise, you'll just, break part of that hard pan or scratch the surface. But if you go underneath that, and then you say if you have, did the deep tillage, then you shatter that hard pan. And that's when you get the benefits. And when it comes to deep tillage, we should always use a straight shanks, not like a moldboard plow thing to overturn the soil. That would not be good, especially for these kind of areas. Even disking is not good. I say that under regular circumstances, deep tillage is just a band-aid. It's like tiling plow going through and then you get a good crop because you rip that layer and now suddenly rainwater goes into that area and you get a good crop. But once the soil will settle down, then you're back to zero. But if you're doing it in combination with your amendments, that will give your amendments an opportunity because it will collect more water. The soil in those spots will collect more water that will help dissolve the amendments and probably push the salts into the deeper depths. Yes, there is a place for it, but under more circumstances, no.
So one more question. I know we're right at 9 o'clock, but one more question. Have any studies been done with native warm season grasses since they typically have deep root systems?
There are 2 very good publications, and I don't know whether I could email you guys those. Those are a work between NDSU and NRCS. One publication is called Cool Season Grasses. Another one is called Warm Season Grasses. And they have tested quite a few grasses. And they rate their hay quality, their rooting depths, and their salt tolerance. The reason I ended up picking all these 5 cool season grasses compared to warm season because they had higher salt tolerance.